propagation of electromagnetic wave. Okay. So there are three types, mostly three types of propagation of electromagnetic wave. So I can give you this example of this TV, that satellite communication and all. Okay, so these are example of like say space wave. So there are three types of wave, I would say. So let us say this is my earth. Okay, so this is my earth, let us say. Okay, so let us say this is my transmitting station. Okay, so this is my transmitting station, and let us say this is my receiving station. Okay, so let us say I have an antenna here. Okay, I have an antenna here, and I have a receiving antenna here. Okay, I have a receiving antenna here. You can see that umbrella kind of. Okay, so what does it do? Basically, I have so outside in space, so outside the atmosphere, so beyond ionosphere and whatever, beyond the atmosphere in space, I have a communication satellite sitting here. Okay, so I am sending this wave. Okay, I am sending this wave. Okay, so this wave goes here. Okay, and this let us say I will represent this communication satellite like something like this is my satellite. Sorry. This is my satellite sitting here in space, and I am sending the wave. It goes there, and then that this is sending this wave here. Okay. So this kind of transmission, this is your TV or the satellite transmission. So this is called your space wave, right? This is your space wave. Okay. So this satellite is a geostationary satellite. You might have heard about geostationary satellite. What is geostationary satellite? With respect to Earth, it always with respect to Earth, its position is or remains always constant, because Earth is rotating.
Yeah.
The satellite also will be changing its position according to the rotation of Earth, and so that's a geostationary satellite. So you send from the transmitting station, you are sending the signal and you are receiving the signal, and this is called your space wave.
Yeah.
Okay. And there are other two types of wave. One is called your ground wave, and another is called your sky wave. Okay. So, like say, I have antenna. Okay, I have antenna, and I have another antenna here. Okay, so I have two antenna. Okay, so this it will go from here to here. So this transmission is your ground transmission. Okay, this is ground transmission, and then there is another transmission which is called your sky wave. Okay, so you know our atmosphere have different layers. Your troposphere, stratosphere, ionosphere, and all that. Okay, so let us say this is my. Let us say this is my, I represent my atmosphere like this. Let us say this is my atmosphere. Okay. So this is my atmosphere. So when I am sending some wave from this antenna, if it gets reflected, at the atmosphere, so it will come like this. So this type of waves are called sky wave. Sky. So it is inside the atmosphere. So this sky wave. Okay. So these are the three types. Okay, so sky wave is kind of the radio wave from the transmitting antenna propagates through the sky to reach the receiving antenna after reflection through ionosphere. So what is happening here? It is getting reflected. So sky wave, it is reflected in ionosphere. Okay. So the one key thing here is like when the frequency of the radio wave is more than 30 megahertz, it will pass this atmosphere. Lesser is the frequency, it will not get reflected, it will pass. Why? Because its wavelength at high frequency, its wavelength will be less, so it will pass through it. If wavelength is high, it cannot pass. If you can see now, its wavelength is very big, it cannot pass. Okay, so beyond 30 megahertz, it will escape the ionosphere.
Not get reflected.
Yeah. So greater than 30 megahertz means escape the ionosphere, escape the sky or atmosphere.
And doesn't get reflected.
So to deal with radio waves higher than 30 megahertz, you have to use this kind of this space wave transmission or whatever. And then we have told that which bandwidth is per watt. Okay. So we have to say greater than 30 megahertz we have to. So our TV signals are greater than 54 megahertz. That means your TV transmission, all that wave is space communication. Okay. Whereas your telephone, that is not that can be sky wave or ground wave depending on the frequency.
Right.
Okay. So now we understood the different modes of transmission. One is your ground wave. So this is your ground wave. So you have these are all RF, electromagnetic RF transmission.
Yeah.
Okay? So whatever we have told about those broadband and all that wired, the fiber optic and coaxial cable, those are basically this. If you use fiber optic, your frequency will be very high and your speed of transmission will be very high. Yeah. No. Those are wired communication. Fiber
optic is not wired, that is wireless.
But we are calling it as fiber optic, no?
You wrote fiber optic as wireless in wireless.
No. Wireless, there are three I have explained you. One is wired. In wired there are two. One is coaxial cable, one is fiber optic. Other one is your wireless.
Wireless is either called space wave.
So the difference between the copper wire and fiber optic, traditional wire, copper wire. That's why the speed is less. Now when this Jio and Airtel they are telling that we are giving you fiber optic. Okay. So they are laying fiber optic wires so that we are able to get such high speed like 1000 Mbps and all that. Okay. So that is about the different types of radio wave and space wave and how they get transmitted. Okay. So that you take a picture, then we will do one more numerical on this.